Okay, so if I follow the orders of math, I think what I would do probably is subtract 1 from this side. And subtract 1 from this side. And that would give me 2x here. And 5 minus 1 is 4, so I get that. And then I guess I would write this symbol here, bigger than. And then I would divide both sides by 2. So kind of the same question we did above. And we get x bigger than 2. So what this means is that if I put, sorry, so I think Braden just joined us here. So if I pick any number bigger than 2, the statements should be true. So I don't want to put 2 in because 2 is not bigger than 2. But let's say I put 3 in. You could do 4 or 5. Then I would get 2 times 3 plus 1. And is that bigger than 5? Well, 2 times 3 is 6, plus 1 is 7. And 7 is bigger than 5. So it seems like at least on this sort of level that this is true. If we think of that being our solution. So x bigger than 2 would work here. So any number larger than 2 should work for us. So I'm going to do the same approach over here on this side here. I'm just going to move something on my screen here. So I'm going to subtract 1 from both sides here. I'm going to subtract 1. So I minus 1. I minus 1. And I'm going to get negative 2x now, because there's a negative 2 there. And I'm going to get 5 divided by 5 minus 1 is 4. And then I have this symbol here, bigger than 4 here. And if I use the same technique I used on the other side, when I solved the other inequality, I guess I would divide both sides by negative 2, or multiply by negative 1/2, multiply by the reciprocal. So if I divide that by negative 2, then I would get x, and I would get x is bigger than negative 2. So I'm just sort of copying that symbol down every time I do this. Okay. Now I'm going to show you just a different way. What I'm going to do is I'm going to solve this question without doing any kind of division or multiplication. So that second step where I divided it by negative 2, I'm going to show you how you can get around using any kind of multiplication and division and see if we get the same answer here. So I'm going to rewrite out the question. 1 minus 2x is bigger than 5. Okay. So I'm just going to do this a slightly different way and just see if you guys agree with what I'm going to do here. So what I'm going to do is instead of subtracting 1 from both sides, I'm going to add 2x to both sides. So I'm going to say I'm going to add 2x here. And I'm going to add 2x here. So I'm doing that to get rid of the 2x on the left side. So I know that negative 2x plus 2x is 0. So I'd be left with a 1 here. So that 1 would be left behind. And then I get bigger than 5 plus 2x. And now what I'm going to do here is I'm going to subtract 5 from both sides. I'm going to move the 5 over. So minus 5. I get 1 minus 5 is negative 4. And the 5 minus 5 would go to 0. And I would get 2x. And I still get this symbol greater than there. And now I'm going to divide both sides by 2. And I get x is bigger than, I should write it the way it's written. I get negative 2 is bigger than x. Now, if I read that backwards, this being x here, that means x is less than negative 2. And you could see here that by using 2 different methods, we get 2 different answers. And so the question is, which of these answers actually is the right answer? Which one's the correct answer here? Because you should get the same, if you're following the steps of algebra, you should get the same answer at the end. It can't give you 2 different solutions unless something's wrong here. So one of these answers is wrong. So let's take our first answer and let's pick any number that's bigger than negative 2. And so I'm going to pick 0 because 0 is easy to work with when I plug it in. So I'm going to make x 0 and see if it's true here. So I take 1, I minus 2 times 0. And that's supposed to be bigger than 5. And I get 1, and 2 times 0 is 0, of course. So I get 1 is bigger than 5. So Martin, true or false? Thumbs up, or I guess there's no thumbs down. Give me a wave. Thumbs up. Okay. So is that true though? Is 1 bigger than 5? Anyone want to chime in? Is $1 more than $5? No, that is false. Okay, but this is not true. Okay, but this statement over here, if I pick any number less than -2, so let's try x is equal to -3. Then I would say that's 1 minus 2 times -3 is bigger than 5. And now that's 1. Now -2 times -3 is actually +6. And 1 plus 6 is 7. And 7 is bigger than 5 here. So this statement is true. So how can we get around that? How can we avoid that? Now, I did allude to this in an earlier video. I didn't make a big deal about it back then, but this actually is the topic for today. And what I want to go to is, I'm just going to rewrite out this part here again that we've already done, which is this part. So I'm going to rewrite that out again below. So if you want to rewrite out that also, because this is sort of the main topic for today. So I just invited Rachel. I hope she's here. Let me see if I can see her.
Can
Rachel.
you hear me?
I can hear you, Rachel. Nice to see you. You've done your hair differently.
I just checked my account, and Evelyn told me I came here as soon as I can.
Oh, no problem. That's okay. No worries. You're just about to get to the exciting part. It's all good. Okay, we're like really close to the exciting part. Okay. Okay, so I'm going to rewrite out that statement again. So it was 1 minus 2x is bigger than 5. And I said I'm going to bring the 1 over. So I subtracted 1 from both sides. And if you're using the addition property, that means if you add or subtract an inequality by a number, you don't have to do anything fancy here. So you get -2x is bigger than 4. Okay. So up to here, everything is good. It's all happy math, normal math, no weird rules you have to remember. It's the next step where you have to write a rule down here. And that is if you're dealing with inequalities, that means these symbols, those symbols there. Anytime you multiply or divide an inequality statement by a negative number, you have to flip the sign. So our next step here, we said divide by -2. So if I divide by -2, I get x, I get 1x. And then on this side, I would get -2. But now, because we divide it by a negative, it also is true if you multiply by a negative, but if you divide by a negative, you have to flip the inequality. So instead of being bigger than, now it is going to be less than. And that's true for any time you multiply or divide by a negative number. So I'm going to give you a separate question. I'd like you to try this one and see if you would flip the inequality or not. So our example here would be something like, let's say 5 minus 2, see? Minus 2x. Oh, Baby Yoda's joining us. Is less than or equal to, let's say 13. So I'll just give you 30 seconds to try that question, see what you think.
Where did Baby Yoda go?
Yeah, Baby Yoda gone?
Yeah.
Maybe maybe they'll come back in again. I'm not sure who that was, though. It's a good figure, though. So Natalie, I missed your voice. Can you tell me what my first step would be? Any ideas?
Why would you ask me?
I missed your voice. Come on.
Okay. Well, wouldn't you minus 5 from both sides?
You betcha. So what would be on the left side now?
Is it still me?
Yeah, sure. Yeah, keep going. Yeah, you're doing good.
Oh, other people can give it a shot too, you know? Gotta
Oh, yeah.
share the love.
Okay. You don't want to go? No? Okay. Natalie's okay. Anyone else want to offer an answer? On the left side, we have fear. Okay. Okay. Good job, Natalie. So negative 2x. We got negative 2x on this side. Okay. Don't feel any pressure. 13 minus 5, that's going to give us positive 8. And so would I flip the sign or would I keep the sign here? Well, all I did was add or subtract a number, really, subtract it. So there's no flipping going on if you subtract numbers, so it's still less than or equal to. But now our next step is we're going to be dividing by negative 2. And so we're going to be left with x on this side, or 1x on that side. And we have 8 divided by negative 2, and that gives us negative 4. And now when we flip the sign, we still have the equal part, so the equal is still there. But now it switches, instead of being less than or equal to, it should be bigger than or equal to. And what I would get you to do is just check. It's really easy to check these questions as long as the numbers are relatively small. So I'm going to pick any number that's bigger than negative 4 and see if it works. So I always like to pick 0 if I can, because that usually makes the math easier. Because I know 0 times numbers is always 0. So if I plug that in, 5 minus 2 times 0 is supposed to be less than or equal to 13. Oh, I think Baby Yoda is joining us again. Oh, I'm here.
I'm
Okay,
here.
awesome, excellent. So x being 0 makes this 5 is less than or equal to 13, and I think 5 is less than 13, so I guess that's true. So the only thing we have to be careful, I'm going to write this in notes now. So so I guess it's important. So when we multiply or divide by a negative number, we must flip the inequality. Singular, sorry, I was trying to get pluralized there. Okay, so let's just try maybe one more example of a step. I'm going to put a fraction in this one because we've kept them all like integer numbers right now. That's probably good to start with. But let's try a question a little bit harder. So let's say you had something like negative 2/3 x plus 3 is less than or equal to, let's make it 5, okay? And so I'd like you to solve the question like we did above so that you get a statement like that, but I'd also like you to write your solution on the number line too. Okay, so remember we drew a number line in previous videos. So I'm gonna give you a minute to try that one. It's a little more complicated, but give that a shot. Okay, so I'm gonna start here. There's many ways to go on this question. What I might do is bring the 3 over, because I know it's going to be pretty easy to subtract 3 from both sides, and then I would leave the fraction maybe to the end and deal with the fraction as a separate type problem. So I'm going to subtract 3 first, but some of you might just jump in there and deal with fractions right away, and that's totally fine too. Okay, so I'm going to get negative 2/3 x on that side, and then I get 5 minus 3, which is 2. And I'm still going to have this symbol less than or equal to, because I didn't divide by a negative. I just subtracted 3. So the only time we flip the signs is if we multiply or divide by a negative number. Okay, so now there's a couple different ways you can go here. I'm going to use that new technique I talked about by getting rid of fractions by multiplying by the LCD. I know in math 11 and 12, this is a really useful technique to deal with really big, ugly questions. So my lowest common denominator here would be 3. So this 2 is over a 1 right now, and the other fraction is obviously over 3. So I'm going to multiply both sides by 3. I could multiply by negative 3 to get rid of the negative, but I'll leave the negative till the last step. So I'm going to times by 3, and there's sort of 2 ways to do this question, but I'll try this way. So let's try this side here. I'm going to times this side by 3, but make it 3 over 1. And I'm going to times this side by 3 over 1. Okay, so when I do that, the 3's cancel. They cancel out. And I'm going to be left with negative 2x is less than or equal to 2 times 3 is 6 over 1 is just 6. Okay, so that's a bit nicer looking because you got rid of the fractions here. And then I'm going to divide both sides by negative 2. So that's going to give me 1x, and then 6 divided by negative 2 is negative 3. And I divide it by negative, so I have to flip the sign here. So I was just going to show one other way here to do this question, which I think, just looking at your guys' homework, I think a lot of you were probably ready for this stage. And that is just doing it all in one kind of big step here. So I'm going to rewrite out this question. Negative 2/3 x plus 3 is less than or equal to 5. And really, one way to get rid of fractions completely, instead of dividing by, or sorry, times by the LCD and then dividing by the 2 as we did last time, is actually just multiply by the reciprocal. So just times everything by the reciprocal. So I still would move over the 3. So I'd say this is negative 2/3 x is less than or equal to 2. And now if I look at the fraction here, the fraction is negative 2 over 3. So the reciprocal of that would be negative 3 over 2. And so I'm going to times both sides by negative 3 over 2. So I'm multiplying by the reciprocal. And this is over 1 here. And if you do this, it'll be one less step for you. So that's kind of nice here. So when I multiply 3 over 2 by 2 over 3, the 3's would cancel, the 2's would cancel. A negative times a negative is a positive, so I just have x. And then I would say I get 2 over 1 times negative 3 over 2. So the 2's would cancel. When we say cancel, I mean they're 1. And this would be negative 3 over 1, or negative 3. Now, I do have to be careful, though, is that I multiplied by negative 3 over 2. So when you multiply or divide by a negative number, you have to flip the inequality symbol. So it is going to switch over to that. Now, that's kind of one step process. But you got to keep track of more things, whereas this is sort of more lock and step here. Okay, so let's maybe do 2 more questions here. Let's try this one here if you haven't started yet. Negative 3x plus 5 minus 5x bigger than 2x minus 8. This notebook lesson actually is going to be on the Google Classroom. It'll also be under the OneNote homework book. So if you did miss something, you can always go back to it and check it again. So maybe I'll give you a minute to work on. Oh, actually, I did say put it on a number line, didn't I? So let's put it on a number line. So number line. So we put a dash here at negative 3. And now we have to decide, are we going to be using a closed circle or an open circle? Well, closed circles are used when we have equals. So it means it can be at that location. So you can say you could be there. And if you're bigger than negative 3, which way would you have to go? If you're bigger than negative 3, it has to be numbers like -2 or 0 or 1 or 5 or 10 or a million or 1,334, 0.5. So that's everything to the right. If you're a big social studies student, you know how much, like, in socials, like, all you guys do is color maps and stuff. So if you're really big on coloring, you have your social studies pencil crayon box handy. I know Mr. Meldrum has one, that you could just put a big dot at -3 like that, and you could really shade. Isn't that cool? Just like shading Germany. There we go. So you can graph it one of two ways. I find most students find this is just a quicker way to graph it up there. Okay, so if you haven't done so, answer this this question here, and then we'll do one more to wrap everything up. Okay, so for this example here, this one up here, I'll give you some more time for the bottom one if you want to try that. But I think what we need to do is get all our x terms together and all our non-x terms together. So the first thing I have to use is what's called the distributive property, which we talked about a little while ago. And that's where you have a number on the outside of a set of brackets. You have to distribute it into the brackets here. So that's going to be -3x minus 15 minus 5x is bigger than 2x minus 8. So -3x minus 15x. And notice that when we did that, I should just review that although there was a plus sign here, like we were adding the 5, we're timesing that +5 by a negative number. So that's why it switches to -15, okay? So that's something you want to be really careful about with all these brackets and stuff. Okay, so I've got -3x and -5x. Well, -3 and -5 makes -8x minus 15 is bigger than 2x minus 8. Now, at this stage here, there's sort of one or two ways you could go. If you want to keep the x's on the left side, which is what I'm going to do because I want to reinforce this idea of flipping, then at some point you're going to be dividing by a negative, which means you're going to flip the inequality. But if you actually brought the x's to the right side, they would become positive, which means you don't have to flip it. But I'm going to do the flip. It's always fun to flip. So I'm going to subtract 2x from both sides to get rid of the x's on the left side. And I'm also going to add 15 to both sides to get rid of the 15 on that side. So I'm kind of doing two operations at once here. So I hope that kind of makes sense. So -8 minus 2 is -10x's. And then -15 plus 15 would be 0. And then I bring down my symbol here, my inequality symbol. And then I have -2x plus 2x is 0. But then I have -8 plus 15. So that's going to give me +7. Okay. So I have -10x is bigger than 7. So now I'm going to divide both sides by -10. Divide both sides by -10. And so now I just get x here, and I get -7/10. And now because I divide it by -10, I wind up getting less than that, less than -7/10. So just to show you that other way, I'll do a little bit quicker here. Where were we here? Right here. If I was to take -8x minus 15 bigger than 2x minus 8, and I just kind of say, well, I'm going to add 8x here. I'm going to add 8x here. I'm going to add 8. add 8. Then they cancel, so I get negative 7 and bigger than. And then I would get 10x here. And then the 8s would cancel. And if I divide by 10, I now get negative 7 over 10 is bigger than x here. Now, if you read it backwards, if you read this first, it actually is the same thing as that. It's x is less than that number there. So there's sort of a couple of different ways you can go on a question like this. So our last question of the day, it is a doozy. So if you want to at least write it down and just sort of ponder, why is Mr. Dixon so mean to us? So why so many fractions in this question? So why don't you at least write it down and take a stab at it? And I'll give you maybe a minute or maybe 30 seconds just to get going. Our time's getting tight here. I know people have other meetings they have to go to. Okay, so I really, if I can get around working with fractions, I always prefer to work with integers. Integers are much easier to work with. And so I'm going to use this technique we talked about by multiplying by the LCD. It is a little bit tricky at first when you try it, but if you do it, it's going to make basically all the fractions go away in one big swoop here. Now, what I might do just to check the LCD here is I'm going to do some distribution. Some distribution of the second set of brackets, or the brackets on the right hand side. So I'm just going to rewrite this as 3 over 8x minus 1/4 x bigger than, now 1/6 times, so 1/6 times 3 over 4. I mean, that is 3 over 24, but what I might do is reduce that. Like I might say, well, 3 goes into itself once, 3 goes into 6 twice. So this really is 1. If you multiply it through, you would have got 3, which is the same thing as 1/8 here. So I might make this as
Careful with your mic, Mr. Dixon.
off there.
Something's wrong with your mic.
Oh, can you hear me now?
Oh, we're back.
You're back now? Okay.
Yeah.
Sorry. Yeah, sometimes I cut out every once in a while. Let me know if it happens again, okay? And I'll fix that. So
okay.
So that should be how we get our 1/8 there. And that's going to be 1/8 x minus, and then we have 1/6 times negative 6 over 1. So really we get negative 1 here. Okay. So when I look at these three fractions, they have an 8, a 4, and an 8. So to me, it looks like the LCD is 8 here. Looks like our lowest common denominator is an 8. So I'm going to take everything here, and I'm going to times every term. I'm going to times every single term by 8. And that's actually 8 over 1. Okay. And I'll do the same thing on this side. Whatever we do to one side, we have to do to the other. Okay. So now I have to times every term by that. Every term over here by that. Okay. So for the first one, I would get the 8s canceling. So the 8s would cancel, and that would give me 3x. Because I would get 8 times 3 over 8. So they would cancel. And then I have 8 times 1 over 4, which is 8 over 4, which is 2x. So 8 divided by 4 is 2. Bigger than, well, 8 times 1 over 8 is 8 over 8, which is just 1x. And then 8 times negative 1 would be negative 8. So it does, I mean, it's a bit tricky to see how that works maybe, but it's much nicer to look at now. It's very pretty. You just have integer values here. So we have 3x, oopsie. We have 3x minus 2x, which is 1x. And then we have bigger than x minus 8. Now, this is also a nice question. If you looked at the last video, you'll notice there's this weird thing that can happen sometimes when you add and subtract values here. So I'm going to move the x's all to one side, and something really strange is going to happen here. So I'm going to minus x from here. I'm going to minus x from here. And what I'll notice is something really weird happens. The x's cancel on us. So we get 0. And then we get bigger than -8. Now, this, sorry, I have an incoming call here. Oops. Let me just get rid of that. There we go. So now this statement actually is a true statement. And we looked in the last video, we talked about if this happens, one of two things is true. If we have a true statement, it basically means
Yep, Mr. Dixon.
is that better?
You're all
Mumble still? Still mumble?
there. You go. Better.
Is that better? Okay, sorry. So if it's a true statement, you get infinite solutions. And all that really means is that any number will work. So basically, generally in math, we say infinite solutions, or you can say all real numbers is another possibility here. If the statement had been false, let's say you got something like 0 is less than -8, so that would be false. Then that means no number works, so no solution. And so it's kind of weird, but if you any number you can think of right now, if you pick 5, 7, 8, -2, -3, and you plug it into that question above, it will work for you. Okay. So I'm going to I'll write the homework on the video here if you just want to write this down, but I will post it on the Google Classroom also. But the homework will be page 230, numbers 1 odds, 2 odds, 3 odds, and 4 odds. But I will post all this on the video too. So I'm going to switch back to our normal video screen here because I know you guys probably have other meetings and I have a meeting I have to go to too. So stop her sharing. And I'm going to engage my video. Where are we here? Oh, there we go. Okay, I'm back. So good to see you guys again. So does anyone have any last minute questions they want to talk about? For those who joined in a bit later, we are going to have a quiz tomorrow. It won't be on today's material. It'll be on the stuff we've done over the last few days. And then we're probably going to be having our test, I would think, next probably Monday or Tuesday. But I will send an email out for you on that. So, oh, good to see somebody. Hello, see a face. Do you guys have any questions or anything, or anything you want to ask? I'm looking at the chat menu, or you just jump in. No, everyone's shy. Okay. Well, I hope you guys are doing well, and this Tuesday will be our day for videos. So please feel free to